Hey students, wanted to do a little midweek lecture here on a couple of items or on cost of quality out of your chapter 8 out of your book. Before I get to that though, excuse me, we are halfway through, and one of the things I wanted to point your attention to is this little survey right here. And I'd love to have your feedback. It's a quick little survey monkey. It'll take you maybe 2 or 3 minutes at most. And that's if you're thinking heavy about it. So, yeah, if you could do that for me, I'd really appreciate it. I know I've already heard from a couple of people, and so it's been very helpful. And part of that survey is giving me some prayer requests, some things I can pray for you about for the remainder of this term. Okay, so let's talk about chapter 8. And I'm not going to get into everything in chapter 8, but I do want to hit this idea of, let me blow this up here, this idea of cost of quality. This is it. Let's see if I can find this here. Okay, it's on page 288. That's where we're looking at. And you may recognize this if you've checked out chapter 8. So here's the thing. Cost of quality has been around since, I think we started using it early 90s, maybe, something like that, when it kind of came on the scene. And it is a lot of work to track cost of quality, but basically here's the idea. Quality is not free, and you can't inspect quality into a part or into a service. And whenever there's a failure, it costs you. If you're going to prevent a quality spill from happening, it costs you. If you're shipping bad product to a customer, it's going to cost you. All right. So that's what this chart is trying to show. So let's just walk through it really quick. Two axes, the percent of defective product or service that's produced, cost. So let's take a look at this easy one here. This is the cost of inspection. And like I said, you cannot inspect quality in, but you do have to do inspection sometimes. So as your defects, your percent of defect product increases, you're going to spend more and more and more on cost of inspection. That means either in labor or equipment. The industry that I'm in, we supply temp labor to businesses that are third-party businesses that do nothing but inspection of products. They go into plants for 2 or 3 weeks at a time and they inspect product because there's been a quality issue. We make good money on that account, okay? And our little running joke in the office is when revenues are down, we need a good quality spill someplace because we know the third-party customers that we deal with are going to be calling us in to go into a plant to help clean up that mess, that quality mess. So that's the cost of inspection. Notice it goes up the more product you have that's defective, the more it's going to cost the company to clean that up, inspect it, separate the good from the bad. Then there's the cost of failure. So cost of failure, think about like this: the cost of it getting to your customer after it's failed. All right. So inspection has failed because you can't inspect 100% in. You're going to let some through. Then you get into cost of failure. They're showing cost of failure as exponential. I noted in some of the reading that maybe it may or may not be exponential. Let's go with exponential though. It seems to be my experience. So the more defective product you have that gets out into the field past your inspection gateway and out to your customer, the higher the cost. Think about recalls. Think about car recalls that you heard about. All those different things that have to be brought back in, fixed, and then sent back out. Huge cost of failure. There's a way to prevent that, and it's this cost of prevention. They got the arrow going this way. Basically, here's why. You can spend a lot of money up front, okay, to have very few defective products. Okay, so you can put a lot of money into like automation to prevent and in lean manufacturing principles, do a lot of stuff up front that may be very costly, but it will reduce your number of defects. Or you can do nothing. Okay, it won't cost you anything and you can do nothing, but you're going to have a lot of defective product. You add these three curves up and you get this total curve right here. And the sweet spot is to be like right about here, lowest cost, but with a mix then of accepting some cost of failure in the field if you can, accepting some cost of inspection, and accepting and paying for some prevention. Now let's take an example. I got a pen here. It's a fairly complicated pen, a lot of little moving parts on here and all that sort of thing. You know what? I probably, as a business owner, would accept I would accept a certain amount of defects especially if I didn't have to pay a lot up front. Because listen, if I'm paying a lot up front to prevent zero defects in this thing, the cost of that pen, the operating cost is going to be so expensive that I'll have to charge a lot and I'll never sell any, okay? So this is kind of like a better option for me. I'll accept some defects, put some inspection in, and inspect some as well, okay? Because after that, once these defective pens get out, if I didn't spend the money over here and I'm not doing, then the cost of failure really drives the total cost up. I got a quick story about this. This is a real life story. Happened to me. I worked for an exhaust company, automotive exhaust company. We made mufflers and pipes and all that kind of stuff. We made them for OE, original equipment vehicles. So in this case, it was a General Motors Trailblazer. It was the first year the General Motors Trailblazer came out, 2003, maybe 2004, something like that. And the Trailblazer was being made at the Newark, New Jersey plant. I think it was in Newark, New Jersey. So we built the mufflers in Marshall, Michigan, the entire exhaust system from the manifold all the way to the tailpipe tip, one big long welded assembly. Shipped them out. We got a call from the plant, hey, these mufflers are rattling. Because when you start a vehicle up and drive it off the line, they can hear a rattle. So we went out there and what we found was, so now you're already hearing, cost of the failure is going up. We flew there, a couple of us. All right, that was the lead on it. We found out that inside of a muffler there's this little baffle, welded baffle that was loose, and it was rattling inside the muffler. They had what's called a yard hold at the GM plant, which means they put all the Trailblazers that are built into a yard and keep them there until we can inspect them. So now our costs are really going up. So we're back at the plant, we're inspecting parts. We're trying to figure out what happened so we can fix the equipment. And now we got a cost of failure in the field because we've got parts in the field. Now, at one point, we did not have enough product go into the General Motors plant, good product. And what happened is we shut the assembly line down because we didn't get them good mufflers to install. We only shut them down by like a minute or two. Okay, I'll get back to that in a second. So now we're thinking about cost of failure now. Okay, but we put parts on the road and big trucks. Trucks to get there. We put them on railway to get them there. We even helicoptered and then flew parts to Newark, New Jersey from Marshall, Michigan to keep their line from shutting down at the General Motors plant. Well, we missed it by like 2 minutes. All that stuff coming in, we shut them down by 2 minutes. The price, you're not going to believe this, the price to shut an assembly line down at the car companies, $60,000 a minute. Okay, we shut it down for 2. They gave us a deal, only charged us $80,000. Felt good, huh? $80,000. That was the cost of failure because we didn't do a good job at this end on preventing the problem. All right. So, anyways, real life example there. And I would also quickly add that if we're talking airplane parts, critics really want to spend more on the preventative side. You can't afford any defects. Okay. Anyways, so it does matter what you're producing. Hope that's helpful to help explain this chart, and look forward to seeing your papers and discussion forums coming up this week. Thanks.